start with the diagram so you can figure out what's happening in terms of x and y. So here's the ball, and the ball is rolling off. That means by the time it reaches the edge of that ball, it's going to start to curve because of that gravity, right?
Yeah.
So what you have here is you start with just the v1 of x.
v1 of x is 2.0
and it's given as 2.0 meters per second. The v1 of y is 0. That is how we know, because it's just rolling off along the x. And it is extremely important to actually label that the v1y is 0, so that you're not reading between the lines. Identify everything that you can, even to the point that this is there and it's not even mentioned. What else do we know? It says the table is 1 meters above, right? So the dy is 1 meter. And upon reaching the edge of the table, it follows a parabolic path, which we know how far along the floor is the landing spot. So here is the table, right? It says how far away from the table is the landing spot. So we're looking for the d of x. That's what we're looking for. Again, because you're looking at the dx, that means you have to incorporate the vx there, right? So the vx will be dx over t. That's formula 1. So the formula that you're gonna need to use in the end is dx is vx times t. That is what you're gonna be ending up with. Now we're gonna we're gonna work our way backwards to, I have the vx, which is 2. Now I don't have the t. So the time that it takes to go from rolling off the table to the bottom, to the floor here, that's the time that we're looking for, which means it has to be affected by the the y-axis, right? Yep. So looking at the stuff that we know, okay, I'm gonna look for the t first.
Well, we could do d equals v1t plus 1/2
so
at.
You look at the formulas that you have. Can I use this one? I don't have the v2.
You know the v2.
Can I use the d equals v1t plus 1/2 at squared?
Yes, we can.
Your v1y, remember, once you use this is all the y-axis. The v1y is 0. That's completely irrelevant here because 0 times a billion is still 0. So now you have the dy, and by cross multiplying here, you got 2 times dy equals t squared. So looking for times g, this will be the gt squared here. So when you isolate the t, you have 2 times dy over g square root, and there is your time right there. Again, you needed to find the time, which is affected by the y component. So we had to find it first. And you will get 2 times 1, which is 2. 2 divided by 9.8.
Square root of that.
And then the square root is going to be 0.452 seconds. Okay, so we have the time now of falling. Then we go back to what we want. So the v is 2.0, that's given, and multiply it by 0.452, and you have the dx.
0.45, right?
So the answer is 0.9 meters from the base of the table. And is the answer given on that one? It is given on that one. Okay, so the trick again, the trick is to split it up, that's all. If I can tell you what is the summary of the projectile motion unit, what would you tell me? One sentence. Split up the motion into x and y component. And if you want to go further, split up the motion into up and down. Those are 2 different things too. Because why is it important to split it? If you have a perfect parabola, why do we figure out, am I dealing with the going up or going down? It depends on what equation you can pick, right? Even though it's mirror image, if I pick the one going up, the v1y is not 0, but then pick the one that is going down, then the v1y is 0, right? Okay, so are there any, does that answer the question?
Yes, it
How
does.
do I know if it's X or Y? Just start with the beginning. How is it moving in the beginning? Okay. Shall we look at this one here with the person playing soccer or football?
Okay, so which one?
Let's look at number 3, Dewey.
Dewey is sitting,
Dewey's sitting on an apple tree.
branch that is 5 minutes upwards.
So this is from,
Angle of 30 degrees to the horizontal.
watch out.
Speed of 12.0 meters per second and around from the field. How long does it take the apple to hit the ground?
If you can make a diagram, do that. Now you don't have to do the tree in detail, but do we know how tall the tree is?
Yes, we know
Okay,
the tree
so
is
there,
5 point.
we know the dy.
meters.
There's the top of the tree. That's where Dewey is sitting. Says she throws an apple upwards at an angle of 30 degrees to the horizontal. So make a sketch. So 30 degrees, she threw it upwards that way. So what's going to happen to the ball? Or this is an apple. So she threw an apple up that way. It's going to go and mirror image
Yeah.
that and go to that same level and continue to go back, to go down that back. Continue to go down until it hits the ground. Right?
Yes.
Once you have a picture, it will help your mind get ready to put all the variables that's given here. Right? So you got your angle of 30 degrees. What do we know? We have a V1.
We have a V1,
That's your V1.
which is V1 equals
12.
12.0 meters
We have the
per,
dy
per second.
and the angle. That's all we know, right? So,
But we can find V1y and V1x.
oh yeah. So how long does it take for the apple to hit the ground? That's the whole trajectory. That's the whole trip.
Yeah.
So what we could do to do this is we could find how much time did it take for the apple to go up to here, right? Because what do we know about, we'll call it V2. What's the V2 at the top?
V2, well, is...
Well, by now you're telling me, well, it depends.
V1, it depends.
There's-
V2y is...
There's V2x and V2y, right?
V2y is 0.
At the top.
But V2x is the same as V1x. We just don't know what the V1x is
Right.
at this point.
So we can figure that out. Do we even need it at this point? No, we don't. So I'm gonna look at this part here, the time that's going down. So, or the one going up, right? So what is the V1y? Let's find that actually.
V1
So this is 12 sine of 30.
Sine of
That's it.
30. V1y equals
6.
Yep.
So V2y is 0, and also we know that A equals, we'll call it negative G on the way up. I'm going to pick the way up.
y equals
And
0.
now you got the time. So formula for acceleration, that's it, right? So T is V2 minus V1 over G.
V
And by the way, that just came from this formula, delta V over T. Okay, that's the one that you mastered in 30S. Acceleration is change in velocity over time.
minus
That's it.
6
So I just isolated the T.
9.8.
Why the V2 instead of V1? Because the Y is not starting from the V.
So this one up here, because I'm calling this one at the bottom V1,
Y, V1, Y.
V1Y, there's V1Y and V1X. So when it reaches this part of the projectile, I'm calling it the V2 now on the way up. That's the end of the going up part. So it's no longer gonna move up and down. So V2Y is 0.
V1 of Y is 0 and then
No, well, yeah, on the way down now, on the way down, yeah, that would be 0 here. And then that would be whatever you started with. Okay?
So T equals 6.61 seconds.
So 0.61, if can anyone confirm that one? So we got this 0.61, so V2 will be, again, remember these are all y-axis. So what's our V2y or V1y?
Our V1Y.
is 6, okay.
Yeah,
And then, so 6 divided by 9.6, yeah, so essentially 9.8. So you got 0.61 as the time there.
Yeah, it's
That's the answer.
0.6122.
That's it, 0.6122. So that's the answer to A. How long did it take? Oh, we're not done.
No, we're not done.
It's not to reach maximum height.
No,
So
it's to hit the ground.
yeah, so to get this part right here, this is gonna be 0.61 times 2.
Up.
So up and down,
0.61
right?
times 2
So it would be
0.61 times 2 equals
1.22.
and then you have to figure out the time it took to go down all the way to the bottom, to the ground, right? Now, we're dealing with this part of the parabola. This is still a parabola.
Yeah.
But we know the dy is 5
meters.
meters tall. That's the height of the tree.
We do not know the
We
distance.
know that this is going to be, I'm going to call this one V3 and this V4. Okay? So V3y is not 0 in this case. That would be 6 meters per second. Okay?
V3 would be
So 6 here, and you started with 6 here
equals
for the
6, yes.
V1 of y. Okay? V1y 6 is going to match that down up here. The V4, we have no idea what that is. And we're looking for the t, right? So again, the easiest way is to solve for the t going this way. T equals V3y, V4y
Three or
minus V3y divided by g.
3 divided by G.
So how do
But we don't have the V4y, so
How do we find the V4Y?
we can use this formula.
So V2 squared. V2
That's the
squared
generic formula that you will see
V1 squared
in your
plus
formula sheet.
2AD
Okay, so this will be 6 squared. Remember, that's what you're starting.
V2
6
squared equals
plus 2 times
6
9.8
squared plus
times
2
5 square root of that.
9.8 and 5. Okay. So the square root of bracket 6 squared bracket
So now we found our, we're calling it V4 of y. Be mindful again, you're dealing only with the y-axis here. You have to label them X or Y, okay? So
it's 11.6, yeah.
So now that we have the V4, this is the T that we're trying to calculate here. Now we know the V4Y is 11.6. Are you guys following? We good?
Just give me a second.
So now,
Yes.
now this is what we know. I'm just gonna mark it with an orange marker here. We know this one here. We know that part right there. We know here. This is what we just found out.
11.
It's 11.6.
Minus
Okay.
6 over 9.8. So T equals 11.6 minus 6 equals divided by 9.8.
So we'll just reduce, we'll just
Point
round it off to
0.57
0.57 seconds, okay?
Seconds. And then it
That
should.
one.
And then it should.
So this is what we just found. We're looking for time here, right?
2
So we now know the time it takes to go up,
0.57.
the time it takes to go down, and the time it takes to go all the way down to the ground. You're gonna add all those together, and your answer is the total time is 1.22. I'm gonna write down the full work here so you know. So 1.22, which is up and down, this is 1.22 seconds right there, plus 0.57.
1.79.
The answer is 1.79 seconds it will take for that apple to hit the ground.
Yes. And that's just A.
That's just question.
Were you able to follow that?
Once you got question A, that will help us with question B as well. Because question B, what is the total distance the apple travels from the tree trunk? So remember, here's the tree trunk right here.
Which is your
Dewey
up and down.
standing right here,
So we're
throws
gonna-
the apple, and then it lands right there.
So we're looking for dx.
So that's the entire dx.
Actually, we're looking for or r.
The r is just that part right here.
Oh, okay, yes, that's right.
We need to find that little d right here as well. So we need to find that little dx there to find the total dx.
So r, and this is d.
So how do you get the r? Go to the r equation, right? So r is v1 squared sine of 2 theta over g.
Squared.
What's our v1?
Sine 2.
V1 is 12
over.
squared sine of 2 times
So-
angle of 30
So
divided by 9.8.
R equals, so
6 squared is 12.
yes.
So
R-
sine of 60,
Sine of 30 is 60. So 12 sine of 60.
is that okay?
Okay, just give me a second, because it should be 12. Is it 12? 12 squared? I thought when you were v1y was just 6 meters squared.
The V1 is given as 12. The V1y is 6.
Oh,
We need to
okay.
use the V1. Okay, so the
Okay.
range equation incorporates both x and y component now.
So it's 12
Okay,
squared.
so we got this so far.
Squared.
We need to find that little t. So remember, it has to do with the x-axis.
It's not-
So we can
just a
use,
sec. Just write it over 9.8. Okay. Now I'm understanding this. 12
What's our
squared
Vx?
Equals 144. 144. Sin bracket 2 times 30.
what is the time it takes to go just that little bit?
124.
That little bit of time right here.
Over 9.8.
We calculated that in A. What was that? Let me just go back.
That's so 124 equals, and you said it was 12 points.
Okay,
So, so that's R, and then figured out we figured out its range.
okay,
and
let's just see if you guys are following what I'm doing here. So this is the formula that I need to find that x component distance, right?
VXT.
We need to find the Vx first, which is 12 times cosine of 30, okay?
12
Regular
cos
vector,
30
times the time which we found in question A.
12 cos 30 equals 10.392.
So, this is the distance.
0.57 seconds. dx equals 10.392 times 0.57.
So this is the total distance along the x.
So then
That's the answer.
5.23, or 12.2